Sugod na ta!
Algebraic operations of matrices. Algebraic operations of matrices involves equality of matrices, addition, subtraction of matrices, multiplication of matrices. Equality of matrices. Two or more matrices are equal if and only if they have the same number of rows and columns, and their corresponding entries are also of the same value. For example, you have a matrix A with elements 3, 1, and 4 for the first row, 1, 1, and 6 for the second row, 4, 3, and 0 for the third row, and you have the matrix B which is identical to your matrix A with the same values of the first row, second row, and your third row. Your matrix A is a 3 by 3 matrix and your matrix B is a 3 by 3 matrix. So they are both 3 by 3 matrix with the same values, the same elements, and the same position. Thus, we can say that your matrix A is equal to matrix B. Addition, subtraction of matrices. Two or more matrices can be done adding, subtracting the corresponding entries of two or more matrices which have the same size. So given, illustrated, you have a 3 by 3 matrix, so therefore, we can operate the addition and subtraction of matrices. So matrix A plus or minus matrix B is equal to, then, the first element of your first row is equal to your A11 plus B11. For the second element on your first row, you will have your A12 plus B12. For the third element of the first row, you have A13 plus or minus B13. For the first element of the second row, you have A21 plus or minus B21. Then for the second element of the second row, you have A22 plus B22 plus minus B22. For the third element of the second row, you have A23 plus or minus B23, and so on. Multiplication of matrices. Multiplication of matrix can only be accomplished only if the number of columns of the left-hand matrix and the numbers of rows in the right-hand matrix are equal. Multiplication is accomplished by multiplying each element in each right-hand side matrix column, adding the products, and then placing the sum at the intersection point of the involved row and column. Given below, you have a 3 by 3 matrix and a matrix B of a 3 by 2 matrix. The resulting matrix of a 3 by 3 multiplied by a 3 by 2 is a 3 by 2 matrix. If you will have here your matrix A times matrix B, the first element of your resulting matrix can be solved using the first row of your matrix A and the first column of your matrix B. The first element of the first row is the result of your A11 times B11 plus A12 times B21 plus A13 times B31. For the second element of your first row, we need the first row of your matrix A and the second column of your matrix B. Thus, your second element of the first row is equal to your A11 times B12 plus A12 times B22 plus A13 times B32. For the first element of the second row, now we will need the second row of your matrix A and the first column of your matrix B. The second, the first element of your second row is equal to A21 times B11 plus A22 times B21 plus A23 times B31. For the second element of the second row, we will have your second row of matrix A and the second column of your matrix B. Then it will be A21 times B12 plus A22 times B22 plus A23 times B32. And so on for the third element or the third row of your resulting matrix. If you have a matrix of 3 by 3 multiplied by a 1 by 3 matrix is equal to a constant, then the resulting equations will be look like this. It is A11 times x plus A12 times y plus A13 times z equal to its constant. This is known as the equation of unknowns.